Alright, so for this section, we're going to talk about the properties of logarithms. So something that I mentioned before yesterday in my video was the change of base formula. This is when what the change of base property allows us to do is to use our calculator to estimate something that does not have a base of 10. So remember yesterday I said if we have something that looks like this and our base is 3, we need to change the base if we're going to evaluate using our calculator. So I'm going to break it up so that the log of 23 is the numerator, now it has a base of 10, and the log of 3 is in the denominator. I can also use a natural log, so if I want to use a common log or a natural log, I'm still going to get approximately 2.85. Okay, so again, the change of base property, you're going to take the log of the bigger value over the log of the base, and you're going to end up with that value. Either, again, you can use your common logarithm or your natural logarithm. Let's go ahead and rewrite this as a ratio of a common log and a natural log, so we're doing two things. And then we're going to use our calculator to evaluate the log, and we're rounding to 3 place values. So when I'm rewriting it as a common log, remember that's a base of 10. So I'm going to take log base 5 over log base 8. So I just finished rewriting it. The next thing I want to do is write it as a natural log. So ln of 5 over ln of 8. And now we want to evaluate it to approximately 3 decimal points. So go ahead, put it in your calculator, and check your answer with mine. Okay, so let's evaluate our solution after you put log of 5 divided by log of 8. Remember that you have to break it up, close the parentheses out from the top, then hit divide log, close out the parentheses for the bottom so you don't accidentally get an error in your calculator. And your solution, round to 3 place value, should be approximately 0.774. Alright, so let's talk about some properties of our log. So we have our product property, our quotient property, and our power property. What our product property is, if I have a product of something, I can break it up through addition. So for example, if I had log base 2 and I have 4 to the power 4 times x here, I can break it up as log base 2 of 4 plus log base 2 of x. However, this can further simplify. Think back to yesterday. I can rewrite 4 as 2 squared. And now that I have this, this is an inverse property that we talked about before, and this is going to reduce, and we're left with the exponent. So our solution here for this little side example is 2 plus log base 2 of x. Let's take a look at our quotient example. Our quotient example is if you have a quotient, you can break it up through subtraction. So here, this would be log, let's say for example, the same numbers, 2, 4 over x. I can break it up as log base 2 of 4 minus log base 2 of x. And then 4 can be written as 2 squared, so again that's going to be 2 minus log base 2 of x. If you have an exponent here, you can pull the exponent to the front. So I can pull it to the front and then I end up with this. So for example, let's say I have log base 2 of x to the 3rd power. I can pull that exponent to the front and I end up with 3 log base 2 of x. So now we're going to use those properties in this example. We're going to use the product rule to expand each logarithmic expression. So let's go ahead and start expanding. This is going to be log base 3. Remember, multiplication means I'm going to break it up through addition, plus log base 3 of 5. And 9 can be rewritten as 3 squared. So that's 3 squared plus log base 3 of 5. This reduces, we're left with 2 plus log base 3 of 5. Let's take a look at our next one. Remember, if no log or no base is expressed here, that means that the base is 10. So I can break this up. Log base 10 of 1,000 plus log base 10 of x. However, this can be rewritten. Remember, your base is 10 and 1,000 is 10 cubed. So this is log. I'm going to put the base here so that way you recognize that this is going to reduce in just a moment, and we're left with 3. So I'm left with 3 plus log of x. When remember division, I used my quotient property. So I'm going to rewrite this as log base 5 of 25 minus log base 5 of x. And 25 can be rewritten as 5 squared. So log base 5 of 5 squared minus log base 5 of x. Now these are inverses, so we're left with 2 minus log base 5 of x. Alright, so here we have a couple things going on. I can break this up through subtraction, and then I'm going to pull this exponent to the front. So ln e to the third power minus ln of 7. And now I want to bring this exponent to the front. So that's 3 ln e minus ln 7. And ln and e are inverses. And remember, ln, the base is e. So then I can clearly see that they're inverses. They reduce, and we're left with 3 minus ln 7. Okay, so in example 3, it says use the power rule to expand each logarithmic expression. So I'm doing a little bit of a combination of everything. So here, I'm just going to pull the exponent to the front. So we're left with 2 log base 5 of 7. Nothing else reduces, so we leave it alone. For b, I'm going to pull the exponent to the front, and then I'm going to go ahead and simplify if possible. So let's take a look at this one. Alright, so this is what we have, and I'm going to go ahead and I'm going to pull the 4 to the front. When I pull the 4 to the front, we're left with 4 log base 2 of 8 times x. So now that I have that, I'm going to go ahead and I'm going to break this up because it's the product through addition. So that's 4 log base 2 of 8 plus 4 log base 2 of x. Notice how I kept this consistent because this is what's in front of 8 times x. 8 can further simplify as 2 to the third power. And then I can do a couple things. I can recognize that this is inverses, so I'm left with 3. Or I could pull the exponent to the front and then recognize that they're inverses and reduce it. So basically we're left with 4 times 3 plus 4 log base 2 of x. And 4 times 3 is 12 plus 4 log base 2 of x. In our next example, we just want to rewrite this expression with an exponent and then just pull it to the front. So that when you do that, it's going to look like this. Log x to the power of a half, and now pull that exponent to the front. So your answer is 1/2 log of x. Okay. In the previous example where we pulled an exponent to the front on a, another option could be to distribute the exponent, then pull it to the front. So I'm going to just show you a little variation so that way you can see that you have options. So ln 6 to the 5th power plus ln e to the 5th power. So I distributed the exponent first, I broke it up through addition because it's multiplication, and now I can pull the exponent to the front. When I do that, I have 5 ln 6 plus 5 ln e, and ln and e are inverses, so that reduces. We're left with 1, and we're left with 5 ln 6 plus 5. In example 4, I want you to expand each expression as much as possible, and if you can simplify, go ahead and do that. Alright, so let's take a look at A. Okay, so here's A. How we want to begin this is, remember, you can either pull the exponent to the front first or distribute, your choice. I'm going to bring it to the front first. So we have 2 log base b of x. The square root of z, let's rewrite that with an exponent, so z to the power of a half. Remember, when you have the product of two terms, you can separate the log through addition. So that's going to be 2 log base b of x plus 2 log base b z to the power of a half. But now I have an exponent that I can pull to the front again, right? 2 times a half is 1. So we're left with log base b of z. So our answer is 2 log base b of x plus log base b of z. All right, so here's the next example. This is b. So I like to bring my exponents to the front first. So I'm going to go ahead, bring this to the front. Let's rewrite it. So that's 3 log base 5. And remember, when you have the quotient of something, you want to break it up through subtraction. So that's going to be 3 log base 5, 25, minus 3 log base 5 of y. This component is simplified. However, this component, I have log base 5 of 25 that can be evaluated. 5 to what power is 25? Good. So I can substitute this with 2. So that's going to be 3 times 2, which is 6, minus 3 log base 5 of y. All right, so I was just asked how I ended up with 2 here. So remember, what we had was 3 log base 5 of 25. I can rewrite 25 so that it matches this base. And that's going to be 3 log base 5. 5 squared is 25. And when these are the same, they reduce and we're left with the exponent because they're inverses. So we have 3 times 2, and that's where I got the 6 from. All right, here's the third part of our examples. So remember, when we have the quotient, we subtract it through, we break it up through subtraction. So we have ln 10 minus ln e. Okay, that's an L and that's an E. They are inverses, so this reduces to 1. Our answer is ln 10 minus 1. Okay, so here we have the product of 9 square root 10. I'm going to break it up through addition. So that's going to be log base 10 of 9 plus log, and the base is 10, and I'm going to rewrite 10 with an exponent power of a half. Okay, I know log base 10 of 10 is 1. Remember, there's an implied 10 here. So this is going to reduce and we're left with a half. So that our answer is log base 10 of 9 plus a half. We can not only expand our logarithms, what we can do is we can go backwards, where we have them broken up into pieces and we want to condense them back to the product, the quotient, or bring the exponents back. So I kind of can undo what was done. So let's take a look at some examples. All right, so the first one, our instructions say to write as a single logarithm, condense, and then I'm going to do something in addition to that. I'm going to simplify as much as possible. So not only am I going to condense it, I'm going to simplify it so that way you guys get used to simplifying it. So let's take a look at the first one. All right, so here's the first example. I'm going to bring them back through multiplication because I have addition. That means I'm going to multiply them. So I have 4 times root 8. And now I have a couple options. Either I can simplify root 8 as 2 root 2, or I can start by bringing the exponent, which is what I'm going to write everything in terms of exponents, and that's my preference. So 2 to what power is 4? Good, so that's 2 squared. And then remember, root 8 is 8 to the power of a half, but 8 can be rewritten as 2 to what power? 3, so that's 2 cubed times a half, or 3 over 2. So that's going to be log base 2 of 2 squared times 2, 3 over 2. When the bases match, what do you do with the exponents? Add them. Good. So we're going to end up with log base 2 to the power of 7 over 2. Now, because the base is the same as this value here, what happens? What's my solution? Reduces. We're left with the exponent, right, guys? Okay, so our answer is 7 over 2. All right, so here's B. and I have the difference of these two logs. The bases are the same, so I'm going to go ahead and condense them through division. So we have log as log 6x over 6. And what happens to the 6's? Reduce, and we're left with log of x. Alright, because the bases are the same, I can go ahead and condense them. I'm going to bring this 2 back, and that's going to be log base 3, 9 squared. And 9 squared is? 81. Good. So that's log base 3, 81, minus log base 3 of 27. So now I'm going to take the difference. Remember, the difference is I can condense them through the quotient. So log base 3, 81 over 27. And that's going to be log base 3. And what's 81 divided by 27? 3. And what is my final answer now? 1. Good. Because inverses, or 3 to the first power, is 3. So my answer is 1. Alright, here's the last example on the slide. How do I want to begin this? I want to begin it by bringing the exponent back. The bases are the same, so I can go ahead and proceed. So that's ln x minus 2 plus ln x to the 5th power. Because it's addition, I can bring them back through multiplication. So that's going to be ln x minus 2 times x to the 5th power. Don't stop here. You want to go ahead and distribute it. Okay, so that's going to be ln x to the 6th minus 2x to the 5th. Alright, one more example just for fun. Expand, use expression where possible, evaluate without a calculator. So we were kind of already doing that in the previous one. I just want to give you guys extra practice and an idea as how do we do that. So here, same thing as what we were doing before. So let's go ahead and expand it. So log base 9 of 81 minus log base 9 of x. This can reduce. 9 to what power is 81? Good. So this becomes 2 minus log 9x. Alright, last example, guys. Approximate the log using the properties of logs given. Log base b of 2 is approximately 0.3562, and log base b of 3 is approximately 0.5646. So without using a calculator, I'm going to think of how can I get 6 to mirror the stuff that they gave me in the given. Well, I know that 6 is the product of 2 and 3, right? So I can rewrite this as log base b 2 times 3. And when I have the product of something, two things being multiplied, I can break them up through addition. Good. So that's going to be log base b of 2 plus log base b of 3. And log base b of 2 and log base b of 3 were given in the given. So let's go ahead and substitute what this is from the given as well as this. Alright, so you get approximately 0.9208. Let's take a look at b. Okay, we want to do the same thing. We're going to break it up. I'm going to begin doing this one by pulling the negative 3 to the front. So that's negative 3 log base b, 3 times b. Now I'm going to break it up through addition. So just like I did before. So that's going to be negative 3 log base b of 3, and that's minus 3 log base b of b. But log base b of b inverses, so we're left with negative 3 times 1, negative 3. And log base b of 3 was in the given as 0.5646 minus 3. Now let's evaluate that. Your answer is approximately. Alright, when you put that in your calculator, you get approximately negative 4.694. Let's round to 3 place values. So again, for these, what you want to do is simplify and then see if you can obtain the components that are in the given, and then use substitution and simplify that using order of operations.